Okay. Last quiz for the periodic. I think it's 2.17, 2.18, whatever it is, you'll find it in the title. Okay. كلها formulas بس you have to understand أول شيء الgrouping بالparallel والseries. Okay. أول شيء let me oh, this is from the morning. So let's say عندك circuit, عندك positive, negative, okay, positive, negative, positive, negative. It's do they connect them? أيوة they do. It goes like this. هيك. اوكي وبعدين خلاص السيركت goes like this هيك. وانا بقول لك انه each cell is 1.5 V. Find the EMF, the electromagnetic force. ال EMF you know it's the sum صح؟ so عندك 1.5 1.5 1.5 بتصير 4.5 V. How about here? كمان each cell will be 1.5 بس حرسم لك اياه in a different way. هيك. بعدين هيك. Okay, خليني make this a bit longer. Okay, again, each cell is 1.5. How much is the EMF? I'm going to tell you now it's 1.5. Why? This is 1.5. But since this one, it's the other way around, you put, usually it's positive, negative, positive, negative. So عندك negative, positive. When you have negative with negative, or two similar charges, two like charges after each other, they cancel out with each other. So Heidi, this 1.5 will cancel this 1.5. And you're only going to count the last. I think this is wrong, actually. Okay, yeah, I'll just take the drawing that's here. Okay, I'll take the one that's here. Ignore the one I have here. Whenever you have, like this would be 1.5, right? This would also be 1.5. But this one here is 1.5 and this last one's 1.5. But these ones cancel each other because it's negative, negative, positive. That's wrong. It should be positive, negative, positive, negative. Okay, so that's why they cancel each other. You get 3. Okay, that's like how it works. That's for series. However, is عندك parallel. عندك هيك. Then you have another circuit. Else another branch. هيك. You have another branch. هيك. And so on and so forth. If you add infinite branches, and the same thing, you said each cell is 1.5, the EMF, no matter how many branches you add, it will always stay 1.5. It will the total potential difference will stay the same, but the capacity of it would increase. Okay, these are all discussed in the notes somewhere. But yeah, so that's why here it's sorry, it's 3. I explained it earlier because 1.5, 1.5, that's 3. Then this 1.5 cancels this 1.5, so you have 3 in total. Okay, here we have 3 electric cells, each one's 1.5. They want you to find the EMF. What happens when the cell are connected in parallel? In parallel, we know that in parallel it stays the same. The potential, sorry, it always stays the same, right? So 1.5, it will stay the same. But here in B, they're saying when they're grouped in series. If they're grouped in series, 3 what about? They're saying correctly grouped in series. يعني هيك. Hold up, let me draw, let me cook. 1, 2, 3. Okay, like this, right? This is gonna be 1.5, 1.5, 1.5. You're gonna get 4.5, right? طيب, how about it's part AA. ما شاء الله. ما شاء الله. Okay. Anyway, the EMF هلا when the two cells are in opposition to the third one. So يعني له هيك. Okay. بعدين I'm pretty sure it goes like this. Okay. This is what they meant. They said the two cells are in opposition to the third one. So these two are opposite to each other, but the third one not. Okay, so here what's going to happen? This 1.5 will cancel this 1.5. What you're going to be left with? 1.5 at the end, right? That is 1.5. Question 3. Okay, here they gave us a table for the current and the potential difference. And then they're saying based on the relation between the potential difference and the current and this resistor, it can be considered a what conductor. أكيد يعني it's obviously ohmic. There's no other يعني solution. Because if you look at the ratio between, you know that R is equal to V over I. If R is constant throughout all the values, that means it's considered an ohmic conductor. Any substance that has a constant or relatively constant resistance is called an ohmic conductor. So if you divide the voltage by the current, you're gonna get in all of these. I don't know how much you get exactly, but 20, you should get 0.6 in all of them. I'm not going to divide all of them. I checked them already. But whenever you divide these two, you're going to get 0.6, 0.6, 0.6. Someone is going to come and tell me, يا أخي, don't you have to convert the unit? Man, يا أخي, حل عني. من الآخر حل عني. أنت you're saying, if we don't care what the unit of the resistance is, all we're trying to see is, does it stay constant, okay? Because if you, okay, let's say you divide by 10 to the power of 3 here. Again, here is going to be divided by 10 to the power of 3 here. Again, divide by 10 to the power of 3. just حل عني. من الآخر. Okay, 0.6, 0.6, 0.6. It stayed constant. معناتها it's an ohmic conductor. Okay, okay. What's the resistance? Now they actually want you to find it. Here, okay, 0.6 would be wrong. Okay, whenever you actually want to find the resistance, you actually need to use R equals V over I, and you actually have to convert the units into the SI units, right? The voltage, it's voltage V, okay, but the current, you can't keep it in milliampere. You actually have to multiply by from milli to normal, milliampere to ampere, you do times 10 to the negative 3, because milli is times 10 to the power of negative 3. So it's going to become, we're using 20, right? So going over 20 times 10 to the minus 3. So we're going to put 12 over 20 times 10 to the power of negative 3. You get 600. Why I didn't do it at the start is because all I wanted to see if I would get the same number every time I divide. That's all I was checking. That would show me if it's an ohmic conductor. Here we need to use. Here they told me the length of the wire is 40 centimeter. Its cross sectional area is 0.2. With the resistivity, they want you to find the resistivity. Okay, what formula do we use here? We use R is equal to the resistivity rho times L over A, right? Now we have everything that wants to find the resistivity. If you rearrange the equation, multiply A on the other side, you're gonna get RA, and then divide by L. You're gonna get rho P resistivity, whatever, is equal to RA over L. What's our resistance? It's 600. What's our area? The area is in millimeters squared. I need to change it to meters squared, right? We can't have it in millimeters squared. If you tell me you do times 10 to the minus 3, you're wrong, but you're almost correct. Usually, to go from milli to normal, you do times 10 to the minus 3. But since it's squared, you also have to square it. With 10 to the minus 3 squared would be times 10 to the minus 6. Okay, so that's when you're converting square, you have to square what you're converting. So instead of multiplying by 10 to the minus 3, it becomes 10 to the minus 3 squared minus 3 times 2. You get times 10 to the minus 6. So it will be, the area is going to be 0.2 times how much? 10 to the minus 6 over the length. The length is 40 centimeter. 40 centimeter. How do we convert it to meter? We multiply centi to normal. It's times 10 to the 9 minus 2. So times 10 to the minus 2. You're going to get, let's see how much. 600 times 0.2 times 10 to the power of negative 6 down and at 40 times 10 to the power minus 2. You're gonna get 3 times 10 to the minus 4. Very, very easy, guys. Formulas. Formula. The potential difference across an ohmic conductor. Its resistance is 50, with volts is 20. It's 12. How much is the current? We know R equals V over I. So I, rearrange the equation, put I here, R down. You're going to get I equals V over R. You're going to get 12 divided by 50, which is 0.24. Okay, guys, please make sure to watch the notes video I published about 12.8. It's very important for the ohmic conductors with resistance. Really, there are some stuff I said that are important. I'm forgetting what I said, صراحة. But I said some stuff about resistance that are very key for ohmic conductors. In general, you really need to watch the notes or do the book at least. Do one or the other, or even if you just read the notes at least, يعني, because I'm telling you, quiz and course division is not enough. And there he's gonna get stuff in the computer that was mentioned in the blue text in the book. The ratio of the potential difference to the current, so V over I, what do we call V over I? We know it's called resistance. 6. Okay, they gave you the resistivity of germanium, so P, or so not P, rho, is 0.48. A wire of germanium has length 5 millimeter. Let's make it into meter. It's times 10 to the minus 3 meter. And area of 1 millimeter squared. Again, let's make it into meter squared. It will be 1.0 times 10 to the minus 3 squared صح. So it's going to become 1.0 times 10 to the minus 6, because minus 3 times 2. Okay, what do they want? They want the resistance of this wire. So we done R. What's the equation? R is equal to rho L over A, right? Well, this is going to be equal to, it's already an ohm meter. It's already in meter. Sometimes they won't give you it in meter. I think in one of the course vision questions, they didn't give it in meter. I still haven't published the course vision video as of the time I'm recording this, but you have to, أكيد do the course vision. It's not even like, it's not even negotiable, guys. You have to do the course vision. It's very important. So rho 0.48 times the length, which we said is 5 times 10 to the minus 3. The area is 1 times 10 to the minus 6. And you should get 2400, but they want it in kilo. Let's solve for 0.48 times 5 times 10 to the power of minus 3. And 1 times 10 to the power of minus 6. 2400, it's in kilo, right? So شو بنعمل? 2.4. Thank you so much for watching, and good luck.